Hi everyone, I am Dr. P. Kumari, working as a Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today in this video, we are going to learn about the general solution of non-homogeneous linear differential equations. Here different methods are there. So in this one, we are going to learn about method 1. So here, first of all, how to solve the linear differential equation with constant coefficients. So first of all, the complete solution of the given equation. That given equation is f of t into y equal to f of x. Otherwise, we can write this one as f of t into y equal to q of x. So for this equation, the complete solution is y equal to CF plus PI. So what is the CF means? F is the complementary function and PI is the particular integral. So for the equation f of t into y equal to f of x or f of t into y equal to q of x, the complete solution is complementary function plus particular integral. So if it is homogeneous equation, that means f of t into y equal to 0, then only complementary function is the general solution or complete solution of the given equation form. So for the non-homogeneous, we are going to find both values, that is complementary function and particular integral. So for the homogeneous equation, only complementary function is the complete solution. So in the previous video, we discussed about the homogeneous equation, how to solve the homogeneous equation and what is the solution of the homogeneous equation. So today we are going to learn about non-homogeneous equation. So here, general solution of non-homogeneous equation is y equal to yc plus yp. So what is the meaning of the yc is complementary function plus particular integral. So here for the complementary function, we can denote with the yc and particular integral we can denote with the yp. So here from the given equation form f of t into y equal to q of x, then we can calculate the particular integral, that is 1 by f of t into here q of x. So in this q of x, we can have the different values. For example, in q of x, we can have e power x and we can have here sin ax also, or cos ax also, or x power k also, or x square or x cube, like that. So here e power ax into x power k also, and e power ax into sin ax also, and e power ax into cos ax also. So like that, in place of q of x, we can have a different values. So for example, here if you are having q of x equal to e power x, we have to follow one procedure. If you are having sin ax or cos ax, so we are going to follow the another procedure or another method. So here if you are having x power k or x power m or x power n, like this, we are having x power x square, x cube and so on, like that. So we are having the another procedure. Like that, if you are having e power ax into b, that means in place of v, we can have x power k also, or sin ax also, or cos ax also, like this we can have the term e power ax into v. So for this also we are having the different procedure. So based on the q of x value, we are having the different methods. So first in this video, we are going to learn about method 1. So what is the method 1 is, here first of all, to find the particular integral based on the q of x value, we are having the different methods. What is the equation of the form here? F of t into y equal to f of x. Otherwise, we can denote here f of x as a q of x also. So f of t into y equal to q of x, and q of x not equal to 0, then this is the equation form. So from this we can calculate the particular integral. What is the particular integral? That is equal to f of t into f of x. Otherwise this is 1 by f of d into q of x. So here, what is the procedure for the q of x value? So here first I am taking the method 1. What is the method 1? We are having q of x or f of x is equal to e power ax. Then what is the procedure we are going to follow here? So first I am writing here what is the formula we are going to use. So that is particular integral equal to 1 by f of d, 1 by f of d into q of x. So in place of q of x, we can replace the e power ax. So for this, we are going to substitute. In place of d, we can replace the a value. If you are having e power ax form in the next step. So that is 1 by f of a, 1 by f of a e power ax. Here, f of a should be not equal to 0. So then, this is the final step. So what we are going to do here, just we are replacing d equal to a. So in the first case, we are replacing here particular integral. So 1 by f of d into q of x. So that q of x value is e power ax. So now, what is the step you are going to do here if you are having e power ax form? So d equal to a. So what is the a value we are going to get here in the e power? We are substituting that value in place of d. So that means 1 by f of a into e power ax. So here f of a should be not equal to 0. If f of a is equal to 0, what we have to do? So we are having another procedure we can follow here. That is, if f of a equal to 0, that particular integral will be becomes pi equal to x into 1 by f dash of d into e power ax. Otherwise, we can write this formula x power k by, so that is pi equal to x power k by k factorial into pi of a. So here pi of a should be not equal to 0. We are doing the differentiation here. So after the differentiation, that f double dash of a should be not equal to 0. So these are the two formulas we can use according to the given equation. Sometimes we can do the differentiation, after then we can replace the a value. Otherwise directly we can write the x power k by k factorial into 1 by pi of a. So here pi of a should be not equal to 0. So here in some of the textbooks they are giving the notations like this. So particular integral of f of d into y equal to e power ax. So what is the working rule we are going to follow here? So we have to put d equal to a. In particular integral will be calculated like this. So particular integral equal to 1 by f of d into e power ax. So here we are replacing the e value in place of d. Then it becomes 1 by f of a into e power ax. Here f of a should be not equal to 0. The same way, if f of a equal to 0, what is the value we are going to write here? That is f of d equal to, we should get this form. This is d minus a whole power k into pi of d. So here the formula for the pi is equal to e power ax by pi of d or pi of a into x power k by k factorial. So here pi of a should be not equal to 0. So if f of a not equal to 0, this is the form 1 by f of a e power ax. If f of a equal to 0, we should get this form, that is x power k by k factorial. So to get the better clarity, we are moving with one example here. Solve the differential equation. What is the differential equation? D square y by dx square minus 2 into dy by dx plus 10 into y is equal to e power 2x. This is the given equation. So from this equation we can write a operator form, that is d square y minus 2 into d into y plus 10 into y is equal to e power 2x. Already we know about the operator. Operator is nothing but d equal to d by dx. So d square equal to d square by dx square and d cube equal to d cube by dx cube. Like this, in place of d cube by dx cube, we can replace d cube value. In place of d square by dx square, we can replace capital D square value. And here d by dx equal to capital D. So from this I am writing f of d. So d square minus 2d plus 10 into y is equal to e power 2x. So now I can write the f of t. What is the f of t? F of t into y equal to q of x here. What is the f of t value? F of t is equal to d square minus 2d plus 10. This is the f of t. So what is the general solution of the given differential equation? That is y equal to CF plus PI. CF plus PI. So that means first we have to calculate the complementary function, after then particular integral. So first we are going to calculate the complementary function by using the f of d. So here f of d equal to f of d is d square minus 2d plus 10. Now we are writing the auxiliary equation. So now the auxiliary equation is f of m equal to 0. What is the f of m value here? In place of d, we can replace m here. So m square minus 2m plus 10 equal to 0. So from this I can write the factor. So m equal to minus b plus or minus square root b square minus 4ac by 2a. We are using that formula, minus b plus or minus square root b square minus 4ac by 2a. Here, this is the formula to calculate the value here, m value. So minus 2 is there. So minus plus 2 plus 2. So plus or minus square root b square is 2 square. So 4 minus 4ac. 4 into 1 into c is 10 by 2 into a is 1. So finally m equal to 2 plus or minus square root 4 minus 40. So 4 minus 40 is, so here 4 minus 40. So that value is minus 36 by 2. So here 2 plus or minus 36, I can write I square root 6, that is becoming here. So we are 6 by 2. Taking the 2 common here, 1 plus or minus 3i by 2. So 2 will be cancelled. M I am getting here 1 plus or minus 3i or i3. So that means M1 value is 1 plus 3i. M2 value is 1 minus 3i. So these are the complex roots. We are having complex roots. What is the complementary function? Complementary function yc equal to. So according to the formulas, complementary function yc equal to, if it is alpha plus or minus beta I roots. So then e power alpha x into c1 cos beta x plus c2 sin beta x. So here what is the alpha value we are having? Alpha value is 1 and beta value is 3. Now we are going to replace here e power x into c1 cos 3x plus c2 sin 3x. This is the complementary function for the given values. So complementary function is completed. So next what we have to find? How to find the particular integral. So here particular integral is pi is equal to 1 by f of t into q of x. So what is the q of x here? 1 by f of d into q of x value is e power ax. So here 1 by f of t into e power x here. So what is the e power x we are having here? E power x is here 1 by f of t into e power 2x. So in place of f of t I am writing the form here, d square minus 2d plus 10. So here 1 by d square minus 2d plus 10 into e power 2x. Here put d equal to a. So what is the a value? 2 here. So now 1 by 2 square minus 2 into 2 plus 10 into e power 2x. Now what is this value? 2 square is 4 minus 4 plus 10 e power 2x. So finally plus 4 minus 4 will be cancelled. 1 by 10 into e power 2x. This is the value of particular integral. This is the value of particular integral. So already complementary function is calculated. This is e power x into c1 cos bx plus c2 sin bx. Now what is the complete solution? Otherwise what is the general solution? So complete solution or general solution is y equal to ci plus pi. CF plus pi. So what is the CF value? E power x cos 3x plus c2 into sin 3x. This is the complementary function plus the particular integral value is 1 by 10 into e power 2x. So this is our general solution of the given equation. This is our general solution of the given equation. So this is the way to calculate the given equation, non-homogeneous equation. So non-homogeneous equation means we have to calculate the two values, that is complementary function and particular integral. Then final solution is y equal to complementary function plus particular integral. So we are moving with one more example here to get the better clarity. Solve the differential equation, that is t square plus 5 into d plus 6 into y is equal to e power x. So here what is the f of d? So f of d is d square plus 5 into d plus 6. So now what we have to find? We have to find the general solution. What is the general solution? That is complementary function plus particular integral. So first I am calculating the complementary function. How to calculate the complementary function? So from the f of t, first I have to write the auxiliary equation. Now the auxiliary equation is f of m is equal to 0. What is the f of m value? M square plus 5m plus 6 is equal to 0. So now I am writing the factors here. So m square plus here 6 is, so 2 3s are 6. So I can write the operators here, 2m plus 3m plus 6 equal to 0. Now take the m common, so m plus 2, and take the 3 common here, again m plus 2 equal to 0. So m plus 3 into m plus 2 is equal to 0. So finally m values are minus 3 comma minus 2. So now I got the values, root values are minus 3 minus 2. That means these are the real and distinct values. So what is the complementary function now? yc equal to c1 e power minus 3x plus c2 e power minus 2x. So now this is my complementary function. That means one value calculated. Now we are going to calculate the particular integral. So how to calculate the particular integral? Particular integral equal to 1 by f of t into q of x. So here 1 by f of t is t square plus 5t plus 6 into q of x value is e power x. Q of x value is e power x. Now here I can write the operators. So d plus 2 into t plus 3. Now here e power x. Now what is the procedure you have to follow for the e power ax? Put d equal to a. So what is the a value here? 1. So finally here 1 by 1 plus 2 into 1 plus 3 into e power x. Now so 1 by 3 into 4 e power x. Finally what is this value? 1 by 12 into e power x. So this is the particular integral. So particular integral equal to 1 by 12 into e power x. So already complementary function also calculated, that is c1 e power 2x and c2 e power minus 3x. Now finally general solution is yc plus yp, that is y equal to c1 e power 2x plus c2 e power minus 3x plus particular integral. What is the particular integral value? 1 by 12 into e power x. This is our general solution. This is our general solution. So I am moving with one more example here. See the example. Solve y double dash minus 4y dash plus 3y equal to 4 into e power 3x. So here including conditions we have to solve. So what are the conditions they given? Y of 0 equal to minus 1 and y dash of 0 equal to 3. So first of all, for the given equation, we will follow the procedure what we done for the previous problem. So first, the given equation is we can write. So y double dash means d square. So d square y minus 4 into y dash is d. So dy plus 3 into y is equal to 4 into e power 3x. Now I am writing the operator form d square minus 4d plus 3 into y is equal to 4 into e power 3x. So from this I can write f of d. So f of d equal to d square minus 4d plus 3. So what is the general solution for this? So general solution is complementary function plus particular integral. So from this first I am going to calculate the complementary function. So how to calculate the complementary function? First we have to write the auxiliary equation. What is the auxiliary equation is f of m is equal to 0. So in place of d I am replacing m. So m square minus 4m plus 3 equal to 0. Now I am writing the factors here. M square minus 3m minus m plus 3 is equal to 0. Take the m common here, m minus 3 and take minus 1 common. So m minus 3 is equal to 0. So finally m minus 3 into m minus 1 is equal to 0. So what are the m values? M values are 3, 1. So now I got the roots are two distinct roots and real. So complementary function yc equal to c1 e power x plus c2 e power 3x. This is our complementary function. So that means first part is completed. Particular integral. How to calculate the particular integral? So here pi equal to 1 by f of d into q of x. What is the q of x value? What is the f of d? We are going to replace here. F of d is d square minus 4d plus 3 into e power. Here 4 into e power 3x. 4 into e power 3x. Now 4 is the constant, taking out and writing the value here d square minus 4d plus 3 into e power 3x. Now what we have to write here? So put d equal to a value. What is the a value here? 3. Now I am replacing here. First I am writing the operator form. So that is d minus 1 into d minus 3. d minus 1 into d minus 3. So e power 3x. Now 4 into, when I am replacing the 3 value here, first value d minus 1. So there is no issue for the first, that is d minus 1. So when you are replacing here d minus 3, so 3 minus 3 is 0. So here this is becoming 0. Don't replace the value here. So here this is pi of a and here f of a. So if f of a equal to 0, what we have to calculate? If f of a equal to 0, what is the formula? So formula equal to x power k by k factorial, and we should have the d minus a whole power k. So based on that formula I am writing here, this is 4 by 2 and e power x by d minus 3. By using that, so x power k by k factorial, k value is 1 here. So 2 into x power 1 by 1 factorial e power 3x. So finally this value is 2 into x into e power 3x. This is the particular integral value, that is 2 into x into e power 3x. So now I calculated particular integral also. So what is the general solution? General solution is y equal to complementary function plus particular integral. What is the complementary function? C1 e power 3x plus C2 e power x plus here particular integral is 2x into e power 3x. 2x into e power 3x. So this is the way to calculate the complete solution of the given equation. So if f of a not equal to 0, then only one step is enough, that is t equal to a, we are replacing. If f of a equal to 0, we have to do another step as like this. So I hope we get the clarity about this problems for the method 1 of a non-homogeneous equations. For more examples, you can refer these textbooks. So this is B.S. Gravel. Author name is B.S. Gravel. So textbook title is Higher Engineering Mathematics. So here, and one more textbook also is there, a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal. And one more textbook is there, that is Higher Engineering Mathematics written by B.V. Ramana. And we can refer one other textbook also, that is Engineering Mathematics. Engineering Mathematics written by D.K.V. Iyengar. So these are the textbooks you can use for the reference to get the solution for the remaining problems also. So please get the more examples to get the better clarity about this type of problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.